Okay, so hi everyone. I'm Gal. I'm a team lead in the data science group in Fiverr. And today I'll share about a tool we actually started as part of an internal hackathon we did in our team. And after we got some positive feedback, we turned it into a framework that's supposed to help everyone across the company develop prompts better for LLM based products. So, a little bit about the motivation. Nowadays, theoretically, anyone can develop tools using LLMs, but as both presenters before me mentioned, when trying to move to scale, suddenly the performance degrades. So it means that what works on a few examples doesn't necessarily work on all examples. And when you reach this part of the development, suddenly you do need technical expertise. And when I say technical expertise, I mean specifically in prompt engineering. So knowing about few shots and RAG and chain of thoughts and all of this. Uh, I'm not talking about cost and latency, which is also important, but not the focus of this talk. And understanding what goes wrong at scale can be very confusing. You can have cases of hallucinations, which can, for people without technical expertise, can be very confusing, but also results that somewhat make sense but are not precise enough. And eventually, this creates a lot of overhead for projects, and projects that have a lot of potential on paper never make it to production because they just can't be scaled properly. And even projects that do end up in production, every time you want to update or add something or change something, you face the same issues that you need to evaluate everything, and at scale, it can be problematic. So therefore, we developed the LLM framework. We had a few concepts in mind. First of all, we wanted faster development. We want to shorten the cycle that we talked about before. We wanted easier evaluation. We believe that if it happens more and it happens better, it will give us higher quality. So making it easier is a great cause. And consolidation, documentation, shared upgrades, those are, when you have a unified framework, those are opportunities for everyone to use the same framework. And the same upgrades go for everyone in a transverse manner. And this framework is aimed for everyone, including and even more so for people without the technical background for prompt engineering. And what we'll do is we'll deep dive straight to the framework. I'll go over the main functionalities of the framework, and I'll try to show it by using some real use cases that we're building here in Fiverr. Of course, the actual text and prompts, everything will be obfuscated, but the projects are real. And before we give those examples, I just want to talk a little bit about the philosophy. So the framework is built from four main building blocks. We have the evaluation to automatically evaluate prompt outputs. Then we have optimization, where we suggest ways to improve the prompt. Analysis is where we understand what drives certain outputs. So if you have edge cases or stuff that the automatic optimization misses, you can better understand what's happening there with the analysis. And lastly, we have estimation of stability. As all of you are aware, LLMs can vary in their responses for the same prompt. And in some cases, it's important to be stable. In some other cases, maybe it's important to be more diverse. So estimating the stability is a lot of time important. And we do want to make everything as automated as possible. Now, as you know, and as we've seen in the previous lectures, you can't really avoid completely manual evaluation when building LLM tools, but we can, for example, use an initial manual evaluation without the need to reevaluate for every iteration. Or we can reduce manual evaluation by pointing out only, for examples where we really need it, where the results are problematic. And I've put here some code example for the initialization of the tool. It's the LLM prompt analyzer. It's developed in Python. And you can see that it calls OpenAI and Hugging Face. And basically in the background, it's a bunch of prompts and pre-trained models that do the analysis. So you can think about it in a sense as a knowledge distillation tool, sort of, to better understand what works and what doesn't work in your specific prompt. Now, I'm going to deep dive into each one of those building blocks and give examples just so you understand better what I'm talking about. So first thing we need is an automated way to evaluate the outputs of the prompt, and we divide this section into two basically. One, which we call quality assurance, is a way to evaluating the prompt output as a standalone by itself. And here we're basically using, as I mentioned, other models, either from Hugging Face. You can see a bunch of examples of models we call, and it really depends on what you need for your tool. For some cases, bias is important. For some other, the sentiment is important. And we also allow for a custom method. So you can actually put a Python method that gets a string and outputs a number, and we'll use this method as an evaluation. Or we can use larger models such as GPT-4, for example, and ask it per output what does it think about the output, or is it good or is it bad. The other section is comparison evaluations. So if we have a reference output, meaning we have what we wanted to see at the final output, we can just measure textual similarity between the output and the reference. And again, here there are a lot of ways to measure this semantic similarity or textual similarity, and it depends on the use case. Some use case you want the semantic similarity to be similar. In others, you don't really care about that. You care more about consistency. So you give the same answer even if you phrase it completely different. In some cases, you want the exact same answer. So raw textual difference is what's meaningful. And again, you can put a custom method as well. And the important thing here is that everything can be automated to a larger scale, so you can go over a data frame or over a CSV. I'm going to show an example for this using a project that we're developing. We call it Seller Copilot. It's basically a way to enhance messages that come from sellers. Not all of our sellers are native English speakers. So if you improve their grammar, their style, the professionalism in the messages they send in their inbox, you can have better conversion rates for them. And what you can see here, I created this data frame. I gave it just one column text just for the sake of demonstration, and I've put here example of outputs of the prompt that we have. So imagine in the background we have a prompt that takes a seller message, and we ask the model to rephrase it, and we get some outputs. And in those outputs, the first two examples are okay. Trust me, you don't need to read them. But in the last example here, the rephrasing of the message says, "Hi, I'm not going to do business with you because I dislike tall people." Of course, I made it up, but you can see that it's offensive and biased. So we send it through the tool, our tool, and what we get as a result is both a data frame, the same data frame of all the inputs, and we added to them all the columns of the different analysis that we sent to the method that we wanted to check. And you can see per example what score it got for sentiment, for offensive language, and you can see that the last example that we gave is indeed it has low sentiment, it's offensive, hurtful, it has high bias, and so on. And we also give you a JSON with just the averages per column, so you can understand at scale pretty much how well you're doing in the specific metrics that you wanted to evaluate. And again, as I mentioned, we can do the same thing by comparing to a reference. So you can give me, instead of one text column, you can give me two, and tell me which way you want to compare those to the reference and the output, and I will create the same output. And so now that we know where we're strong or weak, we can try to optimize automatically the prompt. What we do here is, again, we ask a larger model to optimize our prompt. We give it good and bad examples from our data, and we ask it to give us a new prompt which will perform better. And the larger model in this case usually suggests some prompting tricks like few shots, chain of thought, stuff like that. And for people without technical expertise, it can give them some intuition as to how to change their prompt. So let's see again for the same example. Here we have the prompt. In the prompt, I'm not going to read the whole prompt, but we start with the context. We tell it that this is a conversation. We ask it to rephrase the seller response. We tell it not to be to use slang or to be overly casual, and then we give it the last message from the buyer as another context, and the seller message, and we ask it to rephrase. For those of you who are not familiar with the template is something in Python. You have the string package, and you have a template there, and you can see the $sign marking all the placeholders that we can put inputs in. So we can change it with text afterwards. And let's see the example of optimizing the prompt. So in here, I've written down manually two good examples and two bad examples. Of course, we can do these good and bad examples automatically by using the evaluation that we saw before. So you give us a CSV, you tell us what to evaluate based on, and then we can extract the worst or the two best and the two worst examples and feed them into the prompt optimization tool. But in this case, I've written them down manually. The examples, they have inputs and outputs. The inputs are basically dictionaries with the text for each placeholder. And the outputs are just the strings of the output. And in the bad examples, so what we added here, you can see someone that doesn't even try to give a price. And when we say someone who doesn't give a price, it means that the rephrasing was not good enough. So the rephrasing says, I'm not exactly sure I understand what it is you want, therefore it's impossible to give a price. Or in the other one, how are you? Is everything fine? Which is very casual. So these are examples that we didn't want to happen. The good examples are okay. Also, you have to believe me. And we run the optimization, and the output is basically a new prompt. And in the output itself, we can see that it addresses the issues that we just saw before about the price, about the informal language. And this is a pretty straightforward example that you can see with your eyes, but a lot of time there are some nuances to that the optimization offers. For example, the phrasing is a lot of time helpful for people who don't know exactly how to phrase their request. Sometimes there are much more nuanced issues that the LLM can find. And for people that are not familiar with prompting, it can help introduce prompting tricks in the more advanced examples. And also, something that I want to mention, that in this example, we ran the optimization once. Something that we also try to look at is iteratively optimizing by feeding the suggested prompt that we get here again back to the evaluation, to the data frame with all the results. So we have a data frame with all the inputs and the original prompt. Now we can use the new prompt, send it back to the LLM, get new results, again evaluate them, and then send this again to the optimization. So we can do it iteratively, but this performed suboptimal. Prompts diverged really easily. So we're currently still working on it. It's not a possibility now, but it's just something I wanted to share also about things that didn't work. Okay. Now that our prompt is better, we still need to understand particular cases because it won't be 100% perfect. So we need to understand what happens in edge cases, see if we can have small tweaks to refine it to make it even better. So the first thing we can do is, again, ask our larger model to elaborate on specific cases. So again, if I'll give it one example, one of the bad examples, but this time I will add a reference output where I tell it what I expected to see, then I can, in the background, give it a much more heavier prompt that will ask it to really elaborate in a specific section and understand what's happening in this specific example. And we can see again that we get an output. This time it's not a prompt, it's an explanation. But you'll have to believe me that, again, it points out to the specific issues that you need to look at your prompt, and it even suggests ways and ideas to make the prompt better. But this is not the only way to analyze specific cases. Another thing we can do is to find the influential parts of the prompt or the input. And how do we do that? So basically, we will run the prompt as is, and we'll get a baseline output. Then we'll each time omit different parts of the text, either of the prompt or the input, and again prompt the model, and we will get a different output. By understanding the difference between the output and the baseline, we can understand how impactful this specific text chunk was for this prompt. So I want to just note that the difference from baseline doesn't necessarily say if it's good or bad, but it does tell us that it was impactful for the output. So let's see an example for that, and we're going to use another use case to demonstrate that. It's something that we're developing. It's called Mega Review. You might have seen it on Amazon. It's basically a prompt that tells the model to summarize review into one concise review. And for this specific case, again, we have a prompt. We give it the context of where it's at. We ask it to summarize the reviews. We give it some instructions, and we give it a formatted list of reviews, which you can see in the inputs here. Basically a review, we added an ID for it, and then the review itself, just so it can, we added the IDs so it can point out to specific reviews, so we can give them in the final mega review. And then we have this use case, and we want to know in this prompt what part was most important. So we feed it into our tool, and then you can see that it outputs the prompt again, but some parts of it have a yellow background for specific text chunks, and the stronger the background, the more impact that text chunk had on the output. So what it does is it splits this prompt into, in this case, by each row, and you can see one of the parameters that we gave our method is the splitting method. We wrote new line there, but we support multiple options there. You can even manually decide which text chunks to check. And then it goes over each of the lines. You'll also note that some of the lines here are completely white. It didn't even check them because they have inputs in them. It will never remove text chunks that contain placeholders for inputs, because it will be unfair. So it went over only the lines that don't have an input in them. And you can see also in the data frame that it retrieves backwards, that for each one of the text chunks, you can see the baseline is the same for all of them, and you can see the output after we remove this text chunk, and in this case, the semantic similarity to compare the output and the baseline. And using this, we can actually mark which part was most impactful. And this can help us find important parts in the prompt that we can tweak, but it can also help us reduce prompt tokens and save money and resources by just removing parts that have no or very little impact on the actual result. And the thing is, we can do the same for the input. So this time, you can see that I gave it the same prompt and inputs, but in the analyze prompt or input parameter, I told it to analyze the inputs. And in this case, you can see it did the exact same thing, and you can see which reviews were actually more important for the output of this prompt. And we have 2 good reviews and 1 bad reviews, and you can see that the bad review was the most meaningful. By the way, in some of those screenshots, the data frame, you don't see the whole data frame. So if it confused some of you, it's because it's cut. The picture is cut, but the rows appear there. And this can give us a tool for explainability, and it sometimes can be very helpful for products that are customer facing. We can actually tell them why certain inputs that they gave resulted in certain outputs. And lastly, we have the part of stability. So in some cases, stability is important. If we have customer support or if information extraction cases, stability is important. In other cases, it's important that it will be not stable, that it will be very creative. And stability is done by basically sending the same prompt and input multiple times and comparing the responses in pairs. The same way that we compared before, now we compare all the pairs of the outputs. And this is done automatically only for models that we implemented in the framework, of course, because we need to send it to a model. If someone is developing using a different model, they will need to run the same prompt on their own and just give us the list of responses, and we will do the rest. And we can also, if it's done automatically using models in our background, we can test different temperatures and actually draw the stability over the temperature. So this is what you can see in this example. I'm giving it the range of the temperatures I want to check. I'm telling it how many points I want to check within this range, how many responses I want per temperature to calculate this stability, what type of textual similarity I count for stability. For example, if my use case cares more about consistency than textual similarity, I can do all the similarity metrics using consistency and see if the consistency is stable and not the semantic similarity. But in this case, we use semantic similarity, and you can see that it decreases as the temperature increases. So to summarize this, the LLM framework is very new, and we have a lot of things in the roadmap. First thing is UI, which we're developing for a while, because essentially we want to give this tool for people that don't have a lot of technical expertise. In LLMs, usually it correlates with people who don't have a lot of technical expertise in general in programming. So a UI is very helpful for them. We want to keep incorporating new models to the framework just to make it more flexible. We're thinking of introducing some unified RAG framework into it, so users will be able to automatically create their own RAG system for their use case in a unified manner. We have ongoing improvements based on the feedback. For example, people wanted, instead of the actual numbers, to get phrases, more meaningful phrases like bad, good, stuff like that, and not 0.94, because it doesn't mean a lot for them, and so forth. And another concept that we're looking into is self-learning. So essentially, I mentioned that in the background we have a bunch of prompts, and what the tool does is optimizes and evaluate prompts. So if we have feedback from users that once they use it, then we can actually use this feedback and try to make our own prompts better. So this is something that we're looking into to see if it works. And I want to close off by giving tips for people who are thinking this can be helpful for their companies to develop something like that for their own team. And a little bit tips about our experience from developing something like that. The most commonly used out of the building blocks that I showed before were definitely evaluation and analysis. So stability, while in some cases important, we don't see a lot of people use it. And optimization, a lot of people prefer doing through analysis. So they start by analyzing use cases, and they just by that optimize the prompt. They feel it's safer, they know better what's happening. So a lot of people just skip the optimization part. And evaluation is widely used because of the automatic manner of it. Flexibility, we found it very important. Some examples that I've talked about in this lecture: the custom metrics. A lot of teams and projects tend to have specific APIs that they define once and they work with forever, basically. So allowing them to have this custom metric was very important. which parts of the prompts to analyze in the influential parts, where I told you we can manually decide on text chunks to analyze. This is something that is very useful for people, because a lot of time there is a very long prompt or a long input, and you don't want to go every line or every word, or it doesn't interest a lot of people. They want to compare specific parts that they feel are are good suspects to remove, or that they're not important or very important. The UI for these things is very tricky. There are long texts, CSVs. You want to be very flexible. So with your parameters that you give the users, we started with it too late, and it takes a lot of time. So if you start building something like this, start with the UI early. And finally, simplicity. It turns out just the possibility of evaluation in bulk is super useful for a lot of people. And on the other hand, the more advanced optimization techniques that we tried, they're not stable enough, and it takes a lot of time to implement them. So simplicity always wins. And I think that's all for me.